Well, good morning. This is 9:31 on Tuesday, the 18th of April, 2017. Supposed to be pre-calculus trigonometry. Unfortunately, I'm the only one in the room. Now, last week I know we missed 2 days because of my doctor's appointment and Honors and Awards Day, but we have class today. We're supposed to have it. Hopefully some folks will be coming in. But anyway, I'll get started from where we left off last time. We did have class, remember, the Friday before last week to make up the one that I missed for my doctor's appointment, but I didn't feel as obligated to make up the one for Honors and Awards Day because that was a school function, not my doctor's visit. And here we have the Gil. What happened?
I was playing basketball last night. I went to the plant, and my knee gave it out, popped.
Oh, no.
I'm not tore something, but the doctor can't see me until Thursday. So
Oh, I see.
I emailed you and told you I wasn't going to make it today,
Okay.
but I didn't want to miss today and Thursday, so I went ahead and came. And it doesn't hurt to sit down and start to walk on that real bad. So.
Right. Okay.
But yeah, we don't know what it is yet. It's like an MCL or ACL or something. Hopefully it's not all the way torn.
That's what?
Hopefully it's not all the way torn through.
Right. Yeah. I not played basketball, but planted a foot last week. Sometime I was going somewhere, someone stopped in the front, I stopped, my foot caught, and I thought, oh no, because it didn't pop.
That's what happened to me. I went to stop and plant and jump at the same time. Like I went to stop, I was in front of me, and he was going to take a charge.
Right.
So I didn't want to, so I went to jump, go over him, and when I jumped, playing at the same time, and he just,
Yeah.
I got hyperextended it a little bit.
Yeah. Okay. Good to see people getting here. I was being all alone. Okay. So Landria is here. It seems like so long, I've forgotten names are. Dejarian's not here yet. James not here yet. EJ's here.
I don't know if you sure we were out on both days yesterday, right?
Last week. But we did have a makeup class the previous Friday, and that's out there on YouTube. Jasmine's not here yet, and Tyler is kind of here. Sorry about your leg. All right, the rest aren't here yet. Hopefully they'll be coming in.
I'm not going to make it Thursday, I don't think. I'm going to get the doctor. So
Okay.
what I need to do to make up that, just watch the thing online?
Yeah, for sure. I'm going to give you your test today, so you can be working on that in the doctor's office. So, but hopefully that'll be healing and getting better. Sorry about that. Okay. A couple of other announcements I wanted to make. One is, already done those. The student course evaluations are open now. Okay, that's y'all are familiar with them, right? Done them before. Please do those. You don't have to do them right away. Very good. You don't have to do them right away, but I would say it's a better idea to do them early than forget about them, okay? Because at the end of a term, especially at the end of spring term, you're so eager to get out and get summer started that it's real easy to forget to do student course evaluations. So please do those. But if you do want to wait until you've seen the final and done all that kind of stuff, that's okay. But just don't forget to do it, okay? And just a reminder, there's no way any instructor will ever know what you put down. All we see is a composite. We do not see individuals. Now, we do know whether or not you've done an evaluation, because they do list that, but there's no way we see what you put on the evaluation, okay? So, and if you were thinking this, the first person who does it, there's no way we'll see that either, even though we'll see it. They don't show us any composites until they have 4 or more students or something like that in there. So you don't have, there's no way you can tell who said what. Not that any of us, are going to be looking for that, but it's just impossible to do. So please do your student course evaluations sooner rather than later, but later is fine too. Also, for those who are graduating, the CAP exam, they gave it yesterday. I don't know if they're still giving it today, But if you are finishing this term, I think you're highly recommended that you take that. It can't hurt you at all, but it might actually be get a real good score. You can put that on a resume as something you scored this well on it. So it can help. It's the College Achievement Proficiency Program or something like that. It's just a test measuring, I think, 3 areas: English, reading, and math. To show where you stand among other people of your peers, and hopefully that's quite good. Okay. What's that? I don't know how to answer that. In fact, one student said he was told not to take it, but that was by other students. It wasn't by, I think they really would love you to take that. I know I want you to, not to see your scores, but I like to measure what kind of job we're doing as instructors to see how people do in math. And generally, y'all do pretty well. So I would say do it. Okay. Now, any questions on anything? Like I said, we did have class the Friday before last week, and where we did the first part of middle part or whatever of 5.5, and we're going to pick up where we left off that time. So that's out there on YouTube now. Any questions before we get started today? Okay. Last time we did power reducing formulas, which were okay. Very seldom do I set out to say, oh, I want to reduce the power. But built on that is these half angle formulas. And here's what they are. And it's hard to do this without doing the other. The power reducing formula, if you look on the previous page, this was page 384, we're on page 385, you'll see that that formula was this. Let me get my pen activated. That sine squared u is equal to 1 minus cosine 2u, happy cosine 2u, okay, divided by 2, okay? And then there's a cosine, there's a tangent. We're on 385, but I'm looking back to what we did on 384. That was called the power reducing formula, okay? Now, notice what we have here. We have a square of sine of angle u, and on this side we have the first power of cosine, but this 2u, okay? Twice the function. Which means this one right here is exactly half of what that one is, right? So if we made, and unfortunately they use the same letters, but if we let this one be our u, then this became u over 2, okay? Let this become u, that becomes u over 2, and then take a square root, and that's exactly what you get here. Sine of u over 2, if you take a square root, sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u over 2, all in the square root there. Now, how do you know what to do with the plus or minus? That's sort of a thing, which is it, plus or minus? You can't have really two answers, you only need one. So what determines that? Where is u over 2? If that's in the first quadrant, plus. If it's in the second quadrant, plus. If it's in the third quadrant, minus. Fourth quadrant, minus. It depends on where you are, okay? What quadrant you're in with your u over 2. Okay? Now, the second of those power reducing formulas was this one, as I said before. The cosine, bless you, squared u is equal to 1 plus cosine 2u over 2. We did those last time. If you listen to YouTube, you'll see it. And again, doing the same thing we did before, since this angle is twice what this one is. This one is half what this one is. So change that to u over 2 and u, and then take a square root, and this is what you get here. Cosine u over 2 is equal to plus or minus the square root of 1 plus cosine u over 2. So there's your half angle formula for cosine. If you know the angle, you also know the half angle. Okay? Yeah. Which quadrant this u over 2 is in? If that's in the first quadrant, plus. Second quadrant, minus. Third quadrant, minus. Fourth quadrant, plus. Because you know what cosine is. Very good. Then, from the last, we had that tangent squared u is equal to 1 minus cosine squared u, not cosine 2u, over 1 plus cosine 2u. Okay? Now, what you see here in the half angle formula doesn't look nearly as close to that. Okay? And here's why. Okay? You do the same thing you did before, kinda. Okay? Let this be u, both of those be u's, and let this one be u over 2. Okay? But when you go to extend that, that becomes tangent of u over 2 is equal to, okay, you would take a square root of 1 minus cosine u over 1 plus cosine u. Okay? You would usually do a plus or a minus there as well. Okay? Now, that doesn't look anything like this, does it? Okay? Why not? Well, they've done some manipulation to it. Okay? And here's what manipulation they've done. You can either multiply this denominator by 1 minus cosine u and multiply the numerator by 1 minus cosine u. Hey, Aaliyah's here. There you go. Okay, we're on page 385, chapter 5, Analytic Trigonometry, the last section, 5.5, multiple angle and product to sum formulas. We're doing neither of those. We're doing half angle formulas. This is what it is. Okay? Now, we're multiplying this under the denominator, and what you'll notice here is under the radical, this would be 1 minus cosine u squared. Under a radical, you lose the square, okay? And down here, you get 1 minus cosine squared x, cosine squared u, but that, you know, is sine squared u. Well, sine squared u, the square root of that is just sine. So basically, that's where you get this one. 1 minus cosine u over sine u. Because this gives you a square, and that gives you a sine squared, so take the square root of that and you get this. Or, you could multiply the numerator by 1 plus cosine u and multiply the denominator of that. That gives you a 1 plus cosine u squared in the denominator, which gives you that when you take the square root, and this will give you 1 minus cosine squared, which is sine squared, square root of that is sine. So that's why you lose your denominator, your radicals, and you lose the plus or minus sign, because of the tangent u over 2, the signs come out right, the SIGN signs. Okay? So the sine half angle formula and the cosine half angle formula, you have to just keep up with which quadrant you're in to know whether to use the plus or minus. Okay? The tangent works itself out. You can use either one of those forms, whichever is more convenient for you to deal with. Okay? All right. let's do example 5, okay. Find the exact value of sine of 105 degrees. Well, that's not one of my favorite angles, is it? That's not one of the ones we know well. We know 30, 60, 30, 45, 60, 90, and then multiples of that would be 120, you know, and so that is here. Find you, there you are. And I did intend to say this. Congratulations, any of you who were honored at Honors and Awards Day, because it was nice to see so many of my students recognized. That was good. I knew you were good. They knew you were good too. Okay. So the exact value of this, the angles we know are usually 30, 45, 60, 90. 90 plus 30 would be 120. 90 plus 45 would be 135. 90 plus 60 would be one. You keep on. You get the idea. You know those. This is 105. That's not any of those. Okay? But what is twice 105? 210. That is one of our favorite angles, isn't it? Okay? So, we want the exact value of this, which is also the sine of 210 over 2. Right? And that looks like a half angle formula. And what was that? Look across the page. I know above you. What is the sign of the half angle formula? Plus or minus the square root of 1 minus cosine 2, that which is 210. We know that one, right? And over 2. Okay? Now our first question is, do we use plus or minus? How do we determine? Okay, which quadrant is 105 then? Second quadrant. What is sign in the second quadrant? Positive or negative? Positive. So we use the plus sign. So there's the first mystery solved. We use the plus sign, and then we use the square root of 1 minus, and what's cosine of 210? Second? Root 3 over 2. Okay, except that we have to figure out what sign that is. SIGN sign. Remember, cosine starts positive, goes down to 0 at pi halves, down to minus 1 at pi, that's 180 degrees, and you're on your way back up, so your 210 is just 30 degrees past that, so it's a negative root 3 over 2. So it's a 1 minus a minus, so that makes it a plus here over 2. Well, what does that make it? That makes it the square root of 1/2 plus root 3 over 4. Okay? Now that's an exact answer. I think that's probably the one they're looking for. Well, not quite. What they do is rewrite this as 2/4 plus square root of 3/4, which would be the square root of 2 plus root 3 over the square root of 4 is 2. That's the answer they get. Any of those are fine. That's actually a correct answer. This is a correct answer. That's a correct answer. Any of those would do. Now, of course, if you're using web assign, you know, and that kind of stuff. Only one of those is going to be a correct answer, you know, even though they all really are. Okay. So that's the one they were looking for. Does that make sense? Okay. So what you do when you do have one of these weird angles, you know, see if it's a double angle or something or a half angle or something. And depending on which it is, use the formula that will get you what you need. The checkpoint is to find the exact value of cosine 105 degrees rather than sine, so you can do that one very similar, right? Any questions on that? Now, do I sit down and memorize these formulas? Not really. You know, look them up when you need to use them, okay? Not a bad idea to use them a lot and get familiar with them, and then you get to know them, but it's not something worth expending a lot of effort trying to memorize, I don't think, because you just don't use them that frequently. Okay. Need any more time with this? All right, what I'll do is erase this, and we'll see how they did it. Begin by noting that 105 is exactly half of 210. So that leads us to our half angle formula. Using the half angle formula for sine of u over 2, where u is 210 divided by 2, which is 105, and the fact that 105 lies in the second quadrant, so the sign is positive there, the sine of 105 will then be the positive square root of 1 minus the cosine of 210 over 2, and the cosine of 210, of course, is a negative root 3 over 3, so you have a 1 minus a minus, which is 1 plus, and what they do here with just sort of plopping it down there, they didn't show you how, but you're, like I said, this would be 1 over 2 plus square root of 3 over 2 over 2, which is the square root of 3 over 4, and then to get that to be fourths, that would be 2 over 4, so 2 over the square root of 4 would be square root of 2, and this would be 3 over 4, square root of 4 would be 3 over 2. So there's your answer. Positive square root is chosen because sine is positive in quadrant 2. Does that make sense? It's what we did. They just skipped a few steps there, but got the same. All right. Now, they skip example 6, so let's us go back and do example 6. Okay? Find all the solutions for this equation. 1 plus cosine squared x is equal to 2 cosine squared x over 2. Okay? And we want to do it on the interval from 0 to 2 pi. All right. All the solutions when x is between 0 and 2 pi. What would you suggest we do first? What's sort of wrong or a little bit of a problem with that picture? On the one hand, it looks quite nice that you got cosines here, cosines there. In fact, cosine squared in both places. That looks pretty good, right? The problem is they're taking cosines of different angles. One of them's x and one of them's x over 2. So what that means is we need to change one way or another. Which way do you think we ought to go? Okay, is this the x or this the x over 2? Change that into x. Now, if you go up and look at your cosine of your half angle formula, you'll notice this. I'm going to write it down just like it is there. Cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u over 2, all under the radical. Now, the really neat thing here is that guess what? We have a cosine squared u over 2, not cosine u over 2. So basically what I'm going to do is square both sides of that identity. And doesn't that make life nice? Number one, you don't have to worry about the plus or minus sign. They're going to be plus. And number 2, that undoes the radical. Okay? So you lose the radical there. Okay? So that's what cosine squared u over 2 is. Right? So now we write that down. 1 plus cosine squared x, leaving that alone, is equal to 2 times this thing. Okay? 1 plus cosine x, okay, because we're using x's here, over 2. And then the good news is the 2's go out. They've been dating. No, never mind. Okay? So what do we have then? One plus cosine squared x is equal to 1 plus cosine x. Now, how would you go about solving that equation? Because you have a square, let's get everything. So again, not yet. Let's get everything on one side and then see what we can do to simplify. Because whenever you got a square or a higher power, you try to get everything on one side 0. So then if you factor, you can use the zero product principle. If you had things to the first power, you solve for the function. Okay? But this, you try to get it. So let's subtract 1 from both sides and subtract a cosine x from both sides. So subtract 1, subtract cosine x. 1 minus 1 is 0 on both sides. And this gives you cosine squared x minus cosine x is equal to 0. Now what would you do? Factor! And how does that factor? Cosine x times cosine x minus 1 is equal to 0. Now what will you do with that? Yeah, say again. Set each equals 0. Okay, so either cosine x is equal to 0 or cosine x minus 1 is equal to 0. Very good. Now what values of x between 0 and 2 pi will give you, when you take the cosine of it, you get 0. Where is cosine equal to 0? Where is cosine equal to 0? Say again? Sine is 0 at pi. Where is cosine 0? Say again? 2 pi cosine is 1. Huh? Half a pi. Pi halves. Exactly. So this will be x equal pi halves. Okay? Is that the only place where cosine x is equal to 0? 3 halves pi. That's also between there. So 3 pi over 2. Now 5 pi would work too, 5 pi over 2, but that's outside the interval. Okay, so those are the two from there. What do we do on this side? Cosine x, yeah, add 1 to both sides, is equal to 1. Okay, now what values of x will produce cosine x equal 1 between 0 and 2 pi? Where is cosine equal to 1? Yeah, at 0. And that's the only place. 2 pi it is also, but that's outside. You see, the 2 pi is not included there. So this would be x equal 0. Okay? So here we have x equals 0, pi halves, or 3 halves pi. All right, good deal. Okay, let's see what they got. X equal pi halves, 3 halves pi, and x equals 0. Good for them. They also have a checkpoint there, well worth your effort to do that. Any questions? Half angle formulas. Again, I don't bother committing them to memory. I tend to be able to remember the relationships that produced them. And once you do that, you got it done. Okay? If you want to memorize them, you certainly can. That's up to you. But you can always look them up. In fact, if you were working for me and having to use some of this, I'd far rather you look it up and make sure you got it right than say, oh, I think it's this. Well, I don't care what you think. I want to know what it is, okay? So, frankly, I find it far better to look it up. All right. The next, any questions before we move on? The next topic is product to sum formulas. And these are certainly true, but, I mean, the more we do in this section, the less useful I find it. I mean, they certainly are true, they're there, but guess what? You very seldom need them, but they're there. There are other identities and things you can know, okay? Again, I don't commit them to memory. I'll look them up if I need them. And here they are. Each of the following product to sum formulas can be verified using the sum and difference formulas, and that's exactly where they come from. If you remember your sum formula, I'm going to write down all those sum and difference formulas over here. Sine of u plus v is equal to, anyone remember how that one goes? Anyone remember? Sine u cosine v plus cosine u sine v. Okay? If you put a minus sign there, sine of u minus v, then the first one stays the same, sine u sine cosine v, but then you have minus cosine u sine v. I know that's hard to read, okay? Cosine sum u plus v is going to be cosine u cosine v minus sine u sine v. And cosine of u minus v is going to be cosine u cosine v plus sine u sine v. So, why did I do all that? Well, look at this. Sine u sine v, you see that shows up here and here, right? Well, what would happen if you took this equation and subtracted that from it? You were going to get this minus a minus, which would be plus. It gives you 2 sine u sine v, but if you subtract these two, they go away. And here you get cosine u minus v minus cosine u plus v, which is exactly what we've got here. Cosine u minus v minus cosine u plus v, and then take half of it because you had a 2 there. Cosine u cosine v, that's if you added these two together. These two would go away, and you get 2 of these, and that would be this plus this. So what half of this plus this is that. That's where they come from. They're easy enough to derive. I don't see why you memorize them, or even, they're easy enough. Sine u cosine v, there it is right there. And this one and that one. So add those two together, you get sine u plus v plus sine u minus v. These two go away when you add, so you get 2 of these, so that would be 1/2 the sum of those. And that's exactly what you get. Cosine u sine v, that's exactly here, so if you take this one, subtract this one from it, you get 2 sine u, cosine u, sine v. That'd be sine u plus v minus sine u minus v, and then take out of that. So there they are. When do you ever need them? Not very frequently. I mean, why would you? Product of sum formulas are used in calculus. Yes, we do use them once every blue moon in calculus to solve problems using products of sines and cosines of 2 different angles. Yeah, and you can do it, but it's very rare and it's not a huge deal, but it's there. Okay? Example 7 is going to use that. Rewrite the product of cosine 5x sine 4x as a sum or a difference. So do you remember what that is? That's cosine u sine v. What was that one? Do you remember it? Or just look back and see. Look up top of the page and see what it is. So 1/2, I remember that. 1/2 of what? Cosine u sine v. That's what we've got here. It's 1/2 of sine of u plus v minus sine of u minus v. Right? Just look right above it. There it is, right? Okay? Now, what's your u, what's your v? U is 5x, v is 4x. So this will be cosine 5x sine 4x. That would be 1/2 of sine of, what's u plus v? 9x minus the sine of x. That's all we can do with it. There's nothing else we can do with it. It's it. That's it. That's all we got. Okay? And that's all they wanted us to do, was just write it that way. Now, they did take it one more step by distributing the 1/2. 1/2 sine 9x minus 1/2 sine x. Okay. Why? I don't know. There's no real reason. That's what we got. Make sense?
So with the u and v up there, top where it says minus sign off the parentheses is u minus v, just
Yeah.
okay.
Yeah, where the 5x is the u and the
okay.
4x is the v. So then when you do this, u plus v is 5x plus 4x would be 9x. U minus v would be 5x minus 4x. Okay? Now, let's see how they did it. Whoops, I hit the wrong key. Okay. Using the appropriate product of sum formula, we obtained that cosine u sine v, or cosine 5x sine 4x, is 1/2 of sine 5x plus 4x minus sine 5x minus 4x, which is simply 1/2 sine 9x minus 1/2 sine x. Okay? That's all you do. That's all they're looking for. It's not very satisfying, but that's all there is, folks. Okay, there is a checkpoint. Well worth you doing that one. All right. Now, if those are seldom used, these are really seldom used. Product to sum formula. Occasionally, and I really can't think of when you would ever want to do this, it is useful to reverse the procedure and write the sum of trigonometric functions as a product, and that can be accomplished by using the sum to product formulas. Okay? Now, where did they come up with these? Okay? Basically, if you take the ones we had before, okay, like sine u plus sine v, okay, where did you see that? You didn't really see it. It was, well, rather than trying to justify, there they are, okay? You can go back and show them, prove them, and say, oh yeah, that's right. But so seldom do you ever need to do it. If you ever need them, look them up. Here they are, look them up, okay? Okay, I'm not going to say any more about them. I always try to find some way to make them more meaningful. It's just almost a lost cause, okay? You just seldom use them. So if you need them, use them. They are skipping the next two examples, so I guess we need to do them. Okay, let's do them on this one. Find the exact value of cosine of 195 degrees. That's pretty hot, isn't it? Plus cosine of 105 degrees. Okay? Now, not only do you seldom need them, but in order for them to really be useful, they have to be these very special angles that have these very special relationships, so you know them exactly. But if you ever do need it, so which one is this? Look on the previous page, and that's a cosine plus a cosine, u plus v. So here your u is 195, and your v is 105. Okay? Then the third one from the previous page, the previous block, that's the one you use. What does that give you? It's 2 times the cosine of u plus v over 2 times the sine, the cosine of u minus v over 2. Okay? Now, your u here was 195 plus v was 105. What happens when you add those two together? 195 plus 105. Say again? 300, you say? Absolutely. And you take half of that, you get 150 degrees. Okay? Times the cosine of, this time take the difference of those two. 195 minus 105. What does that give you? 90. Divide that by 2 and you get 45 degrees. Okay? So that's going to be 2 times the cosine. Well, what is the cosine of 150 degrees? Okay? Cosine of 150 degrees. Where are you, Waldo, if you're at 150 degrees? Second quadrant, exactly. What is cosine in the second quadrant? Negative. So you know this is going to be a minus sign right there. Okay? Now, what I like to do is do the reference angle for 150. And what would that be? Say again? 30. Okay, 30 degrees. And what's the cosine of 30 degrees? Root 3 over 2. Okay, so that would be minus root 3 over 2. Okay? What's the cosine of 45? I think we know that one, don't we? Root 2 over 2. Okay? 2 will cancel one of those out, and what you are left with is negative root 6 over 2. That's all you can do, and aren't you glad you know that? Okay, I'm sorry. So negative root 6 over 2. Okay. Any questions? Huh? Now, if you think about that, very hard at all. Cosine of 195, that's over in the third quadrant. Well, that's a negative angle, a negative amount. Plus cosine of 105, that's in the second quadrant, that's a negative amount. You're adding two negatives, you better get a negative answer, and sure enough we do. Okay? So that makes you feel a little bit better about it. And there's a checkpoint there by the exact value of sine 195 plus sine 105. And that looks like the first of those sum of the product formulas. Okay. Now, anyone need this up a little longer? Okay. Now let's do an equation. Here's an equation. Solve this equation. The sine of 5x plus the sine of 3x is equal to 0. And they didn't give us any limit on the domain. So you're going to have to do a general solution here. Well, my x's look a lot like my pluses. That's bad. Okay, that's an x. All right, looking at that, that's the sum of two sines. So you're going to use a sum to product formula. And if you look at that, the sum of two sines is the very first one in your sum of product formulas. And that's going to be 2 times the sine of, now here this will be your u, this will be your v. Okay? And what you have is sine of u plus v, which in this case is 8x divided by 2, which would be 4x, okay, times the cosine of the difference of those. 5x minus 3x would be 2x over 2 would be x. Okay, so let's just lose the 2 here. Okay, cosine x, and that's equal to 0. All right. Now, the good news is 2 can never be 0, so you can divide it out. Okay, not important. But you want sine of 4x equal to 0, or cosine x equals 0. That's the two products here. Now, remember when we had multiple arguments? We solved for that first. 4x is going to be what? Where is sine equals 0? Every multiple of pi, right? Now, it's 2 pi for sure, but halfway in between is 0 again, so it's multiple of pi. So this will be n pi, right? Okay, so let's make x then pi fourths n pi fourths, however you want to say it, okay, for any n, okay? Now, where is cosine equal to 0? Say again? Where's cosine equal to 0? Your half pi's, exactly. So that will be pi halves plus n pi. All of the half pi's. Okay? Normally you'd say 2n pi, but then you do 3 halves pi. But yeah, that's every pi you have it. So, so here the x would equal that. So now we've got our solution. X is either equal to I guess, I don't know which way is the best way to write it. M pi over 4, that'd probably be the best way. M pi over 4 or pi halves plus n pi. Okay. Now, I bet you they do it a little more complicated. They do 0, of course, which n would be equal to 0. They do pi fourths, which n equal 1. Pi halves would be n equal 2. 3/4 pi. So actually, the easiest way to write this is this. This incorporates all these, but all you have to do is n pi. Okay? So x equal n pi over 4, where n is any integer. They do show a graph of it, which is pretty interesting. 0, pi fourths, pi halves, pi 3/4 pi. It is very regular where those zeros are. Okay. And there's a checkpoint down there. Well worth you taking a look at that. All right, any questions? Let's hit the last application. Okay? This is example 10. Projectile motion. Ignoring air resistance, the range of a projectile fired at an angle of theta with the horizontal and the initial velocity of v0 feet per second is given by r, which stands for range, not radius, but range is equal to 1 over 16 v squared, v naught squared, that's your initial velocity v naught, okay, feet per second, sine theta, cosine theta. Now, they don't tell you where that comes from, and it's really not all that important, but I'll give you a few hints. Notice we have the units of feet per second, and we have a 16 in there. Well, that should sort of bring to your mind the acceleration due to gravity in the U.S. customary or the British system, English system, is 32 feet per second squared. Half of that is 16. And that's where the 16 comes from. All right? So, wherever r is a horizontal distance or range in feet that the projectile travels. Okay? There's your setup. There's your range. Now, the question is, write the projectile motion model in a simpler form. Okay? Well, what's not simple about this form? You have two different trig functions. Okay? Most of the time it's bad enough having one, so why complicate it and have two? James is here. Okay? Now, do you know of an identity that will take a sine theta, cosine theta, and make it something that only deals with one trig function? And the answer should be, sure we do! Okay? What would they be? Let's go back to our sum angle formulas. Okay? Do you remember what the sine of A plus B is? Do you remember what that one is? Sine A cosine B plus cosine A sine B. Remember that one? Long time ago, right? But here we have the angles are the same. So basically, let A and B equal theta. So what would be the sine of theta plus theta? That would be the sine of theta, cosine theta, plus cosine theta, sine theta. Right? Does that ring a bell? Well, what is sine theta plus theta? That's sine of 2 theta And this is sine theta cosine theta plus cosine theta sine theta is equal to 2 sine theta cosine theta, isn't it? Okay? Well, guess what? That's where we have a sine theta cosine theta, right there. There's that identity. Sine of 2 theta is 2 sine theta cosine theta. So, if we want this to be a 2 here, we multiply this by 2 and that by 2, and that gives you R is equal to 2 sine theta cosine theta V naught squared over, and we had to multiply that by the numerator by 2, so this will be over 32. Okay? And that then would be 2 sine theta cosine theta is sine of 2 theta. I'm going to put my V naught squared in front over 32. That is a lot simpler form. Okay? Now, let's see how they did it. You okay with that? Are you still getting? Got it. Okay. A football player can kick a football from ground level with an initial velocity of 80 feet per second. By the way, that was what we were calling our V0, wasn't it? Okay. And it says, write the projectile motion model in a simpler form. We just did it. We said that R is equal to sine of 2 theta V naught squared sine 2 theta over 32. Believe that's what we got when we did it, right? Okay. So, sure enough, that's what they got. R is equal to 1 over 32 V naught squared sine 2 theta. Okay? Now, based on that, at what angle must the player kick the football so that the football travels 200 feet? Well, 200 feet is your R. So we have 200 feet is equal to the V naught, which is 80, squared, which would be 6,400 feet per second. But it's feet squared per second squared because you squared that. Whew, goodness gracious. Times the sine of 2 theta divided by 32. Okay? Just plugging in here, V naught was 80, so when you square you got 6,400 feet squared per second squared. Sine 2 theta, we got that, over 32. Well, guess what? 32 will go into 64 twice, so that gives you a 200 up here. Now you got a 200 on the left, 200 on the right, stand up, fight, divide both sides by 200. And that gives you a 1 here. Okay? So you get 1 is equal to sine of 2 theta. Now we're not messing around with the units anymore. What angle would you have to kick at? What angle must the player kick the football so it travels at 200 feet? There's your equation that you're left with. 1 is equal to sine 2 theta. Any of you tell me what sine 2 theta, what 2 theta must be there? Where is sine equal to 1? Pi halves. So this would be 2 theta must equal pi halves. So what would theta have to be? Pi fourths. So theta is equal to pi fourths. So he kicks it at a 45-degree angle, and he gets 200 feet down the field. I think Nick wants to sign him up right now. Because 200 feet is about 66 yards. If he can kick that thing 66 yards, let's sign him, okay? That's a pretty good boot. Was it Lance? Was that his name in pre-calculus algebra? What was his name? Sat right next to y'all, you and your cousin. Blair. I'm sorry, Blair. Was it? Didn't he say he was a kicker for Hueytown? Huh? What's that?
He played soccer and he was a boo-boo kicker.
Yeah. Okay. So I don't know if he could kick that far, but yeah. Okay. I doubt it too. All right. So there's that. Let's see what they get. You can use a double angle formula to rewrite r is equal to 1 over 32 v squared 2 sine theta cosine theta. So there's your simpler version, okay, which is 1 over 32 v naught squared sine 2 theta. And then plugging that into the b, your range would be 200 feet. V naught squared would be 80 squared. And you solve that and you get sine 2 theta is equal to 1. 2 theta must be pi halves. And dividing the result by 2, you get theta equal pi fourths. Because theta equal pi fourths, the player must kick the football at an angle of 45 degrees so that the football will travel the 200 feet required. All right. That's it for 5.5. That's it for Chapter 5. That's it. Let's do the vocabulary. Fill in the blank to complete the trigonometric formula. Okay? What is sine 2u? Say that again. 1 2 over 2. Is that what you said? Where did you get that? What's that? 304? 384. Okay. That was sine squared u. This is sine 2u. Okay. A lot easier than that. Okay. I was going to say, that's a new one on me. Okay. This is one we did just a few minutes ago. Anyone remember? 2 sine u cosine u. All right. Coming up with new ones. How about cosine 2u? Happy cosine 2u. What's that? Yeah, this actually has 3 of them, doesn't it? What is it? Cosine squared u minus sine squared u. That's 1. You can do either of the other 2. Okay, we'll leave it like that. What is 1 minus cosine 2u over 1 plus cosine 2u? Anyone know that one? Okay. Second, tangent squared u. Exactly. Tangent squared u. Perfect. Number 4. What is sine of u over 2? Plus or minus the square root of 1 minus cosine u over 2. Perfect. And what is sine u cosine v? Okay. That's one of those I don't think is worth trying to remember, so just look it up. 1/2 sine of u plus v plus sine of u minus v. Perfect. Okay? And the last one, what is cosine u minus cosine v? And again, definitely one not trying to memorize, just look it up. And what is that one? -2 sine of u plus v over 2 times the sine of u minus v over 2. Good. Okay. Homework exercises. Do any of the odds 7 through 13, any of the odds 15 to 19, either 21 or 23 or both if you choose, and 25 is a good one to do as well. Any of the odds 27 to 31, either 33 or 35 or both, either 37 or 39 or both, 41 or 43 or both, 45 or 47 or both, 49 or 51 or both, and 53 or 55 or both. 57 or 59 or both, 61 or 63 or both, any of the odds 65 to 71. Okay? And then you can choose either 73 or 75. Not a bad idea to look at 77, think through that, make sure you understand why it is as it is. And then 79 is a pretty good one to look at too. Sorry. Chapter summary. Lots of good stuff, concentrated form right there, 2 pages, just about everything you need to know in the chapter. Review exercises, you got some problems, and these also have calccheck.com, tutorial help, worked out solutions for odd number exercises. Do either 1 or 3 or both if you need more practice. 5 if you need more practice. Any of the odds 7 through 15 if you need more. 17, that's in 5-1, 5-2. Any of the odds 19 to 25. 5.3, any of the odds 27 to 31 if you need those, or 33 to 41 if you need those. 43 or 55 or both if you need those. 5.4, 47 or 49 or both. Do 51 if you need it. 53 or 55 or both. 57 or 59 or both. And 61. 5.5, 63, 65, 67, 69, 71, 73, 75, 77, 79, any of those you need and want to look at. There's a chapter test. Again, odd number exercises are worked out on calccheck.com, but all the exercises of these have answers in the back. Okay? Now, y'all are acting like you're going somewhere. I don't know where you think you're going. But couple of things while I'm looking for these. I'm not digging deep enough. Here we go. All right. Couple of issues here. Reminders. Number 1, here, one of my best classes ever, right? Only one person has turned in a paper, research paper. We've got just 2 weeks left in the term, this week and next week. That's all, folks. After that, you're losing points for being late if you turn it in during finals week or afterwards. So please get your papers in. Still missing one, test 1. That person's not here. Still missing that. Test 2. Test 2. Test 2. I got the first one in today. The second one's coming in too. Very good. I need those in, folks, because I'm giving you test 3 right now. And it's really bad to have all these stacked up on you like that. So please get your test 2 done. Test 1 if you haven't done that. All right, and that means we're ready for test 3. I've just got to lay my hands on it. I think we got it here. Now, Chevette, did I give you yours? I thought I did. Okay. So, the rest of you, here's your test 3. Okay? 2-pager. Oh, I got it. So it's a little on the long side, but you got plenty of time, and it's working. Will any of you see Amber or any of the other folks that are missing today? Kajarian? They need to get there. And I think we still got a few minutes, don't we? Okay. I guess not. Okay. I'm going to finish the time that we have. What we're going to do next is chapter 6. Now, we're not going to get a lot done in chapter 6. We got class Thursday, Tuesday, and Thursday, but we'll get it done as much as we can. And chapter 6 does cover, let me advance this. Okay. Just want to go over it quickly so you'll know. Yeah, we got 2 minutes, so let me go over as much as we can in 2 minutes. All right. Chapter 6 is additional topics in trigonometry. Okay? We'll start in 6.1, but the additional topics in 6.1, the law of sines, and 6.2, the law of cosines. Hopefully, we'll get those 2 done in the next week and a half, because they're pretty straightforward there. Love to get to do vectors. Vectors are not, that's 6.3, and then vectors and dot products, I don't think there's any way we're going to get there, but they are things you will need if you go on and take physics, okay? And then the trigonometric form of a complex number is 6.5. We seldom get that far, so don't sweat it if we don't get there. But we will start 6.1 next time, which is the law of sines. So I think I will go on and get this from current slide, so at least introduce you to the law of sines. Okay? There are times, okay, what we've done so far with angles and with trigonometry is when you have right triangles, right? Opposite over adjacent, opposite over hypotenuse, all that kind of stuff. But guess what? Most triangles aren't right triangles. In fact, vast majority are not. So how do we solve things if we don't have right angles? That's where you use law of sines or law of cosines. Okay? And I guess we'll pick up on this. We'll start this objectives next time. Okay, we'll start with the objectives.
I just want to be sure, so we got 2 weeks left.
We got Thursday, Monday, and Tuesday and Thursday of next week. So we got 3 classes left after today. And then, when do finals actually start? Do they start on Monday of the following week or Tuesday of the following week? Okay. I've got to check that too. They started the term on a Tuesday for some odd reason, so that's what makes me think they're going to start finals on a Tuesday as well. So I don't know, but I think the final exam would be, and I'm going to give you a take-home next Thursday. Oh, not the day after tomorrow Thursday, but the following Thursday, and that will be your final exam. In fact, it may be 2 parts. One part will be chapter 6, and the second part will be comprehensive. They'll both be pretty short.
Okay.
Okay. Good deal.
I wanted to say something.
What's that?
I wanted to say something when you stopped the video.
Okay. All righty. Let me end it now.